Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. Good morning, dear students. Good morning, everyone. Today we are going to continue from where we stopped last time. Last time we ended with the application of DSP. And we said many things, and we discussed a lot, and by giving some of the structure, how DSP it looks like. Today we are going to continue from where we stopped last time, and we are going to draw some of the diagrams that are going to indicate or indicate the nature of the DSP. So here, without taking much time, suppose if you have a person here, okay, there my drawing maybe would take, for example, suppose this is a person here, then he is speaking, for example, suppose this is a mouse, and then he is speaking in this way, and the voice goes in, remember it goes on expanding in this way. So there it has to come with the analog signal, because when I'm releasing voice, it has to come with analog signal. Suppose this is analog signal in this way, and it goes to any system. Suppose here now we have a microphone. This is a microphone for the mic. This is microphone, and then the signal goes in this way, and it touches the microphone. Remember, the microphone is going to amplify, and it will give some of the signals. Here, for example, suppose here is an analog signal. Of course, it has never converted into this is analog signal, and it will need, as I told you last time, analog to digital converter. So this is the mic. This is the mic here, call it mic, and it goes to analog signal here, and it will go to, if you want, for example, the other, suppose it was an analog computer. That is a device that is going to turn this analog into digital. And then it goes to mic, and then mic converts the signal into using the converter, which is analog to digital converter. Then it will undergo conversion, then through digital analog converter here, and then it will give, for example, some numbers here. To take any example here, any number here, for example. So here we are using DSP. We are using DSP with the help of ADC and the DSC to convert any analog signal here then into these numbers. So this number would have gone into several steps. For example, as I told you, sampling, discrete values, and so on and so forth. So for instance here, if for example it has undergone this, and again it has to give, for example, the output. So you call it output. So the input is going to be through the mic input, and then it goes through the mic, then it will convert. So remember, when I'm talking like this, it has to give out the analog signal. And then the analog signal it undergoes ADC, and that is analog to digital converter, to convert by using digital processor or digital DSP into the numbers and then output can be seen on the other side. So this one, remember, it would be like a chip of I mean any processor. This is a chip. Yeah. So these are the pins. Call it any processor here, and then it converts that one in that way. So the loudspeaker from analog signal. Okay, you call it a loudspeaker, or you can call it loud voice. Then it goes to this side, then it has to go that way. So that is a general DSP definitions. And if you turn this, so this was, suppose if somebody asks you what is a DSP, using this diagram, a simple diagram, by using simple diagram. So this is how you can respond. So you can respond in this way. So that is number one. But also you can have an example. For example, that if you want to do some temperature presentation or any pressure or any sound, you can easily draw your diagram in the same way. But this is the small sketch. Everything that is going to be drawn will follow the same procedure. So I hope you understand what I'm trying to mean. So let me first of all remove this one, and first of all, and then I give you the full, if you are asked to draw and explain, for example, the diagram of DSP. So you can draw and you explain their functions easily, so that everyone can understand. So remember, this course can be applied in our normal life. For example, I told you when it was in the First World War, when people were using a radar system, which was still analog based system. So we wanted to convert this one because the other one had problems of distortion, interferences, and so on and so forth. So now we are going to continue. Suppose you have an input as analog signal. I have a diagram here. And another diagram. So it goes to another diagram here. Then it goes to another phase here. I call it a phase because it is the whole diagram that contains these phases. So we have, for example, in first place we have a analog to digital converter, and also having a digital. This is analog input, analog input, and then it goes to digital inputs. We call it digital input by using digital processor, digital signal processor. Then it goes into DSC, digital analog converter. Then you can get the output signal. So there you can get the output signal at this side signal. I don't know whether you can easily see, but this it will give the output. So the output signal. And the output signal here will be the digital signal, because it has been converted from no, it will be or still be analog, because you have changed the digital processor here. Then it is going to change from there then it will be analog, pure analog output. But this is not what we want. For example, we want a digital processor. So, as you have seen, we are going to use a mic here. We are going to have a mic here. Okay, this is a mic. We call it the mic or microphone. And then we put it in a system, or we were using the analog amplifier. Analog amp. We call it an amp. Then before it goes to analog amplifier, it has to give some bubbling sound. I mean, you know, when you are using a mic, it's going to give some signal. You remember when it is being registered somewhere, it's going to give some of the signals, and those are analog, of course. It will give, for example, here an analog, and of course, still it is an analog, but we have to convert it to using analog to digital converter, ADC. Remember the analog to digital converter. Still we have values like this, the other one like this, in the same way like that. So the signal is going to be converted using analog to digital converter, and then from there using DSP, you can recall the others. It will undergo some of the values like this, the other one like this, in this way. Then it goes to any encoder. You remember the encoding system that is going to give some numbering system here, encoder, and then it will go. Okay, it continues from there. It will undergo a very huge system, that is a digital system. That is going to be a digital system. Call it, I draw it in this way. So in that, there will be, for example, if you want to change the voice signal, you have your MP3 or MP4, so that for example, the image signal can be seen, like as I'm speaking now. It has to be converted in the same way, so that it can be. So here we have encoder with MP3 or MP4. The other time was when this, now MP3 is very small. So the encoder, digital encoder, goes to using MP3. You can have, for example, it can be stored into CD-ROM. Remember, this is a permanent storage, I mean the device that is in the computer. But also we can have some of the temporary memory like RAM. So we in general can call it a memory here, memory. So here we have CD-ROM, which is inside the computer system, and then it is stored. Remember, when you are making information, or as I'm speaking, it is registered somewhere, and that is a storage system. So the storage system is going to help us to retrieve our information once needed. For example, now this is the whole of this box is called, you will call it digital circuit. Digital circuit. And the other one, the former, the other one, this one, this is analog circuit. Analog circuit. Yeah, and the other one, this one, is going to be the mixture of both analog mixture of analog to digital circuit. So you can see, you can understand the whole system here is going to be the mixture Okay, I forgot. All of these are going to be a mixture of analog circuits. So this is the whole system. So you can, for the first time, it is put in an analog circuit using a mic and the amplifiers, and then it's going to be mixed using ADC with AD encoder, and then it's going to come up with the digital circuit, which comprises of MP3, which is going to convert the numbers. For example, if it was a pixels or of an image, they are going to be stored in either permanent storage, which is CD, or the temporary storage, which is a memory. In this case, it can be RAM. For example, it can be RAM, random access memory. So the CD or compact disc, the CD is it can be stored in the same way. So that is a small sketch of the diagram. So an example is like a temperature control system. So if you are using a control system, like for example temperature control system, remember we are going to undergo all these diagrams. So if you can give an example of a temperature control system, in this case, let me just draw a temperature, and it will be similar to this one because that is an example. So you can see you will still use this block of diagrams. So if I tell you to draw the diagram or explaining the DSP, you have to remember this, and this is going to be applied in case when there is any control system. For example, for instance, example of DSP, and okay, you can call it, for example, temperature control system. So this is an example. So suppose if you have a temperature control system, it will be the same way. So you have analog signal, analog. It undergoes some of the block diagram here. One of the block, which is going to be a measuring system, for example. Measuring system, and then it goes to analog to digital converter. In this case, I'm going to analog to digital converter. You can write the full meaning of this, but also there is no. So it goes to using digital or DSP. It goes to digital processing or digital processor, the digital processor. I call it the digital processor in this case, and then it goes to it undergoes some of the diagram here, as I mentioned last time. Then it's going to be digital analog converter. Remember, going to be digital analog converter, and then it undergoes, and remember when it stands to this, remember when it is analog to digital converter, it gives a digital system, and using a digital processor, you can just bring it back using analog way. So this you can get digital here, but here we can get analog because it is the other way around. So in this case, it's going to be passing through a controller. Remember, it is a controlling system. We said it is a temperature control system. We will require some of the controller, and then it will adjust it, for example, to any given signal, adjust it to a given signal, then it can again go a circling system, then it goes to digital system. Remember here it started by putting into the digital system here. When I speak, as you saw some of the voices I mentioned before, when I speak, it is going into the analog system. So here you can say to analog, then it ends up to digital system. Then you can still get your output as digital output as digital signal or digital output. So this is the whole system. So it is an example of a temperature controlling signal, and here we have. So we have the function, for example. How does it look? Well, remember today it is going to be a full of diagrams so that you can understand in case when they say you want to sketch the DSP structure with their importances, for example. So we are still continuing using the diagrams here. It will, I hope you understand what I'm trying to mean. Each and every block is self-explanatory. It is explained itself. So here we are going to also to draw another diagram. This was a temperature control system as an example of DSP. Now we are going to continue using different examples with various sketches or examples. So, but you can see it is reflecting to the other one that we began with when we are drawing some of the sketches here. So we are going to explain each diagram by diagram. So here you have analog, then you have analog to digital converter. You have analog processor or analog processing. You have digital to analog. Then you have analog filter. You have analog filter, and then you can get output. So it's going to go in this way, and then it goes to in this way. So the last one is analog filter. Analog filter. Then the first one is analog signal. Analog. It's going to attach to ADC, analog to digital converter. Then you are going to have a digital. This is a general diagram. Once I tell you to explain the systematic diagram of DSP with its elements. I'm talking about their elements. And this is a digital processor. Digital processor. And the other one is a digital, analog filter. Also, no, it's going to be a digital analog converter. Then it goes to this one. So each and every stage is going to have the behavior. The signal is going to change according to any output. According to the system you are using. So, like for example, if you use analog, this is a filter. Analog filter. This is a filter. So we are trying to. We are trying to filter out the signal that is going to be seen. For example, to transform signal in the purest way or the desired form. So we are at the end. We begin with, for example, if you have like this is analog signal. It's going to pass through the filter in this way. For example, here it's going to pass through some of the filter, and then it will undergo some of the digital processor, which is going to be, for example, here the signal is going to, suppose if you have a signal like this, it's going to be filtered in this way, so that the noise interference is going to be reduced. So I'm explaining each and every step here. So it begins with an analog, it passes through analog filter, then it is converted into digital by using digital processor, and then it's going to be sampled by using the DSP, which is a digital signal, digital analog converter, and then here it's going to change totally. Here it's going to be bold, for example. It's going to be bold like this. This space is going to be very big, right? Because you are just making it to be like an analog signal. And then here, this is where you can just change the digital. For example, if you want to say, for example, here like this, signal like this, then it should be undergo the DS. And then, guess what? After that, it's going to be like the other. It's going to look like the first one, which was input. Let me draw it here. It's going to be like the other one, which is analog, and then it is put into the filter. Then you can take, for example, a pure sinusoidal wave, for example, like this one. So this is a pure analog. So this is analog filter that has changed this one, and then to pure analog signal. Yeah. So this is a full complete. Once I ask you some of the questions, for example, draw a diagram that explains the basic elements of DSP. This is what I expect. And the next slide, we are going to explain the importance, the function of each and every step here. So beginning with analog input, this side, the analog input, we are going to explain one by one and just to get understand. So the question is, draw the basic diagram, a sketch or a diagram that shows the basic elements of DSP. Draw and explain. Now we are reaching to the stage where we are going to explain one by one. So we begin with analog, then we go to ADC, then like that, and so on and so forth. So let me just explain the functions. So yeah, I hope you understand that you have understood the diagram, what it means in this case. So the reason why we are trying to explain this diagram is to know the importance of each and every block diagram of this of DSP. So we begin with analog. Number one, we begin with analog. Two, okay, analog input. In this case, analog input. Remember, it was the first step. Analog input. So the analog input here will generate the signal from a transducer or any communication media. You can, for example, it can look like, for example, as I mentioned from the beginning. Remember some of the examples of signal. The analog signals. We talked about the electrocardiograph signals. For example, ECG that appears in a heartbeat. For example, if the heart is just trying to release some beats. Then that signal that is just coming when the heartbeat is in operation, then that is electrocardiograph signal. Is one of the examples that uses analog inputs. And also the other signal of electroencephalogram, which is a brain signal. So this is a heart signal. We can call it, name it, signal. But also we have electroencephalogram. If it's electroencephalogram signal, which is the EEG. This is ECG, which is a brain signal. These are the examples of analog signals that appear from the input of our diagram. Remember, we said our diagram is going to have from input using the transducers, which are going to convert this signal into a pure analog. But I have mentioned also here, number 2 is going to be the filters. This is a low pass filter. A low pass filter. Remember, some of you who have undergone, for example, electronics, you have studied some of the filters. We have high pass, we have low pass, we have band pass, and these are the filtering systems that we use. For example, if you are using, for example, if you want to remove the high frequency noise, so they are used to remove high frequency noises or noise, and this doesn't go into a pro. So the noise is going to be removed by using this low pass filter system, which was our second step. So I'm trying to explain the functions of each and every block here in our diagram to understand the complete basic elements of DSP. So here, dear students, here this is the number 2, and we undergo the other normal system here. For example, we are going to explain the ADC, analog to digital converter. What does it do? It is used to convert analog signal into digital form, because the digital signal processor accepts the signal which is a purely digital. I told you from the beginning. The essence of this study is to convert the signal into, analog into a digital signal. So that's the importance of. So we have reached to the function of number 3. So we are going to continue to number 4, the importance. So now we talk about the digital processor. Number 4 is going to be digital signal processor. So this is going to process input signal, which is digitally and can be a digital computer, as I mentioned. I showed you in the diagram, the sketch diagram, or any processor that is programmed in a digital form to perform a desired operation in the input signal, and also to hardwire the digital processor. So it's going to make the digital processor to convert the signal, which was purely digital, into analog, for example. So, but before that, before it gets converted purely into digital, it has to get hardware wired. It is going to make some connections. So it is called hardwired. So it's going to make some connections to connections to a digital to analog converter. So before it undergoes pure digital, using digital to analog converter, it has to be hardwired so that the information can be connected to the digital to analog converter, and therefore its function is to process the input signal digitally, but before it hands over to the DSP, then it has to get connected to it so that the pure digital information can be converted easily. So that is the function number 4. You get what I'm saying? Hardware, this is like connection of 2 points. For example, we call it a hardwire, for example, or hardware. Remember, you can call it hardware, but in this case, it is hardwire. So this is like connection from one point to another, as I have mentioned. So in this case, you are hardwiring. Now we move to DSP, which is digital to analog converter. So this is going to give an output signal purely digitalized. So it's going to give the digital output. So remember, when we are explaining these ones, there are some of the crucial words or very critical words that you cannot miss. For example, if you reach to this stage and you don't mention this one, you would have you would have missed some of the points. So if I'm marking, for example, if I'm giving some of the points or the marks, if I don't see the digital output, then it is going to be the marks are going to be reduced, of course, in this case. So the output signal processor is going to be in a digital nature, and it is going to require the final output so that if it is output here, then again it is going to be easier to be conducted into analog again. Remember, the cycle continues, because remember it is digital analog. So you take digital output, then you convert it into analog signal nature, to analog signal nature. So if I told you, if I don't say you are taking this analog pure digital output, so and another function here, we talk about the output filter, as you have seen, the analog filter, or the output filter, which is going to be the final results, is in an analog nature, which is continuous signal. Remember, it is going to be a continuous signal in this case. Remember, here we said the continuous signal is going to be a one-line signal, as I said, and I told you it is a pure analog. So a continuous signal. Remember from the beginning when I was explaining this. So it's going to give this signal, and which may contain the high frequencies. Remember, and this high frequency noise has to be removed using the low pass filter, as I mentioned. So to remove this, you have to undergo again the low pass filter. So the analog to digital conversion, in summary or in brief, we can say from what you have seen here, we can say that the digital the DSP is very useful when the system itself can convert the analog signal into digital signal to give the output. And here the quick summary of what you have seen about the analog to digital conversion. For example, analog to digital conversion. For example, number one, it will convert it will convert continuous analog signal into discrete signal. Converts analog, just make it big, analog continuous signal, or let me convert continuous signal into continuous signal into discrete. You remember from the beginning we said continuous signal has to be converted into discrete signal, or you can call it digital signal. And the other one you can call it analog signal. So the continuous signal can be. So this is what is done in ADC. Secondly, the analog signal can be sampled. Analog signal can be sampled. Analog signal can be sampled at a regular, can be sampled at a regular intervals. And then the last point here, what ADC has to do, the sampled values are then stored in a data stream. The sampled values are stored into data stream or in data stream. Why is this? Because you want to record back, or what they use. They are stored as data streams. Why as data stream? Because you want to retrieve your information again. So the information has to be stored in a data stream. Somehow it looks like a DSP, so that the signal can be converted in the according to their data stream. This is very useful in case if you want not to lose your information. This can be called, for example, the temporary storage. In this case, temporary storage. So this is very important at the ADC level. There are some systematic diagrams that you can plot. For example, if we have this can be shown in the diagram. Remember today we said we are going to talk about the diagrams of these signals. So you can have some signal level here, and then, for example, you want to plot how many signals, for example. Then you have some of the values. Remember, you have some of the values here. You can have some of the values here. So let us begin, for example, at this stage. The signal can move like this, then it goes like this, then it undergoes some of the signal here, then it will undergo like this, then it goes like this, and so on and so forth. So this is the first. Remember, this is time interval with amplitude. This is amplitude samples. Okay, well, I just put it in the way how it can be seen in the proper way. The amplitude samples, amplitude then the other one is time. So this is you are trying to use a filtering. We are trying to sample some of the sizes are sampled in this way. Remember, this one also has to draw some of the sampling system. So in this way. So it is they are sampled at regular intervals. So this interval may have, for example, different sizes. So here can be size, for example, if we begin from here 0, 1, for example, 2, 3. So I don't know, it has to be very small. For example, if it is 0 0.1, 0 0.2, 0.3 like that, 0.4 in terms of meters amplitude side. So it's going to be stored in this. So these are the intervals that we are talking about. These values are going to be intervals, levels. And after this, as I said from the beginning, it's going to be stored in digital numbers in the data stream. For example, if it is, remember, okay, let me erase this one and draw another diagram. So this is the first diagram showing the sampling intervals, and we are going to store our data into the data stream. So here we are going to store them. In this case, it's going to be the same, but the values are going to change. So this on this side, they are going to be digital numbers or values. Okay, so here you can, okay, it is going to be the same thing this time. So it's going to be digitized using the signal numbers. So here it's going to be signal numbers, and this one is going to be digital numbers. For example, 0, 0, 0. Yeah, so I'm going to be 0, 0, 0 at this stage. Then goes to 0, 0, 1. That is number 2. Number 1, sorry. Number 2. Number 3. Like that, and so on and so forth. So it can be like that. So it can be measured in this way. So at these values, they are going to be different. For example, as I mentioned here, it's going to be digital numbers here. Then this side is going to be stored. For example, another signal here. This side, then it will go, for example, to a certain value here. Then it goes to the other one. Then it can go like this one. You can see they are digitized. Here you can easily say, for example, here number 1, 0, 0 like that. So there are signals we are going to be converted into numbers, and you get what we call a data stream. In this case, it's going to be a data stream. Data stream. Going to be data stream. So it is stored into data stream, so that you can easily record these numbers when you require them. The signal can be shown in the future. So if you want these numbers, and you go to directed to this number, and then you can get easily your information.